All right, well, hello, Honors Algebra 2. This is your third and final lesson for this week. We are in section 9.3 about solving right triangles. You will need a calculator, at the very least a scientific calculator, but obviously if you've got your graphing calculator, you can do all the same stuff on it. You'll notice that on the right side of my screen, I have Desmo's scientific calculator pulled up. It's a free scientific calculator that you can get. You just go to desmos.com. Instead of clicking on Start Graphing, you just click on Scientific Calculator, and it'll pop this up, and it's free to use. It's also the same calculator that'll be provided to you on all of your homework on big ideas. It'll also be the same calculator provided to you on the quiz that you'll take on Friday this week if you're wanting to kind of check your understanding and see how you're doing with kind of learning everything. So just as a warm-up, what I'm going to have us do is we're going to run through just how to find values for sine, cosine, and tangent of an angle using your graphing calculator or scientific calculator. So for the first one, you're looking for sine of 90 degrees. So I'm going to type that into our calculator over here, sine of 90 degrees, and hit enter, and that tells me that sine of 90 degrees is equal to 1. Now, if you were not coming up with 1, most likely what happened was your calculator was in radian mode. Notice that when I switched the calculator, and for me that button is right in the middle here to switch between degree and radian, that it changes my answer to 0.89399666636. So if you are also coming up with about 0.89 for sine of 90 degrees, then you need to make sure that your calculator is in degree mode. In order to do that, obviously you've seen how to do that on Desmo's scientific calculator. If you are using your own graphing calculator, you'll need to hit the mode button, which is right up next to second. And about the third option down is an option for radian and degree. Just make sure degree is selected, and you should be getting the same answer that I am. So for sine of 90 degrees, that would be equal to 1. For cosine of 15 degrees, we'll type that in next. So cosine 15 degrees is 0.96 to the nearest hundredth, and it looks like that's where we wanted to round to. Last but not least, we'll find tangent of 75 degrees. So tangent of 75 degrees is approximately 3.73. Okay. So what you're going to find for our kind of notes for this section is that they're going to continue to build on one another. What we did in the warm-up is going to be something that we'll use then in example 1 here in just a moment. The things that we do in example 1 we'll use in example 2, and the things we use in example 2 eventually will lead to us in example number 3. So let's go ahead and take a look at example 1 now. So in addition to finding the sine, cosine, or tangent of an angle, it's asking us to solve for a given variable. So in the case of example A, it's telling us that sine of 23 degrees is equal to x over 15. In order to solve that equation, we would need to multiply each side by 15. And so x would be equal to 15 multiplied by the sine of 23 degrees. And then I can go ahead and type that into my calculator. So 15 sine of 23 is approximately 5.86. So x approximately 5.86. And I believe again it was asking us to round to the nearest hundredth, so then we would be good right there. Okay, so for B, we'll do pretty much the same thing. In fact, if you wanted to try it on your own, you could pause the video. I'm going to go ahead and start working through it though. So to solve for W, multiply each side by 5. And you get that W is equal to 5 multiplied by the cosine of 74 degrees. And so then we just need to type that into our calculator. 5 cosine of 74 is approximately 1.38. Okay, cool. So on C, we get to an example where our variable is now in the denominator rather than being in the numerator. And so in order to solve that, if you recall, kind of our shorter way to solve that, which will be actually very useful today, is to just swap tangent of 60 degrees with y. In fact, that actually gets you straight to your answer, is that y is equal to 3 divided by the tangent of 60 degrees. And then you can just go to putting it into your calculator. So if you take 3 divided by tangent of 60 degrees, we're going to come up with 1.73. Okay, one more here for example number 1. Same idea. So again, if you want to practice this on your own, go ahead and pause the video. I'll go ahead and start working through it now. So again, you're swapping sine of 80 degrees with x. So x is equal to 18 divided by the sine of 80 degrees. And then once again, just type it into your calculator. 18 divided by the sine of 80 is approximately 8.28. Okay. All right. So now, in example 2, we're going to use what we just talked about in order to solve for a particular side of a triangle. Now, in order to do that, we are going to actually have to set up the equation. In order to kind of do that, I'm going to have to take you back a little ways. In fact, this is something you would have seen on the right triangle review if you had worked through it, is something that's called SOHCAHTOA. And maybe that's stirring some memories of days back in geometry last year. It turns out SOHCAHTOA is still something you're going to use in Honors Algebra 2. Here's what SOHCAHTOA does, is it allows you to remember the ratios for 3 trig functions. So those were for sine, you take opposite divided by hypotenuse. Next up, for cosine, you take your adjacent side divided by your hypotenuse. And then lastly, for tangent, you take your opposite side divided by your adjacent side. Okay, so knowing that is going to be very important in these next couple of examples. So let's take a look at example 2a. So example 2a, let's first kind of look at our angle and figure out what 2 sides we have. 8 would be your adjacent side, x would be your hypotenuse. So you need a trig ratio that relates your adjacent to your hypotenuse. The correct one to use in this case would have to be cosine. So we're going to take cosine of our angle is equal to our adjacent side, which is 8, divided by our hypotenuse, which is x. And then what you'll notice is that that looks just like an equation from example 1, where in order to solve, we'll do something similar to what we did up there, which is to swap cosine of 64 and x. So x would be equal to 8 divided by cosine of 64 degrees. And then we could type that into our calculator. 8 divided by cosine of 64 is approximately 8.25. Okay, cool. Let's take a look at another one. So in example B, let's again look at our angle, which is 15 degrees. In this case, x would be our opposite side, 21 would be our adjacent side, so we need a trig ratio that relates opposite to adjacent. That would have to be tangent. So tangent of 15 degrees is equal to your opposite side divided by your adjacent side. And then to solve this one, no swapping of anything, just multiply each side by 21. So you get that x is equal to 21 multiplied by the tangent of 15 degrees. And then we'll type that into a calculator here to get our decimal approximation. So 21 tangent of 15 is approximately 5.63. Okay. And we'll probably jump around. I don't know that we'll do all of these. We'll go ahead and continue with C because we'll get to see a new trig function. So on C, let's take a look at our angle, which is 43 degrees. We've got our opposite side, which is 10. Our hypotenuse, which is x. So to set this one up, I kind of mentioned it to you, is that we're going to use our last trig function that we hadn't used yet, or trig ratio we hadn't used yet, which is we're going to use sine. So we're going to say sine of 43 degrees is equal to opposite divided by hypotenuse. Now again, since the variable is in your denominator, to solve you'll just swap it with the sine of 43 degrees. And so we know x is equal to 10 divided by the sine of 43. And so then we can type that into a calculator and get our decimal approximation. 10 divided by sine of 43 is approximately 14.66. Okay. So I kind of leave it up to you at this point. I can kind of help you with getting it started. For D, looking at 31 degrees, you've got adjacent and hypotenuse. So think about which trig equation ratio you would use there to solve. For C, you've got your adjacent side and your hypotenuse again. So whatever you use on D, you should also use on E. And then for F, you've got your opposite side of 12, your adjacent side of X. Figure out what trig ratio you're going to use, and so on. So I'm not going to work through those with you. Those can kind of be on your own. I would rather get on to kind of the goal of this section, which is to be able to do what's called solving a triangle. And guys, solving a triangle is one of those skills that I hear all the time from college algebra trig teachers and pre-calc teachers, that they wish their kids were better at solving triangles. It's such a just kind of basic skill that you guys need to have going into next year. So that's part of the reason why I wanted to make sure we got through it this year. So that's what we're going to start with on example 3. And again, we probably will not work through all of these. I'm going to try to get through as many as possible, but I definitely don't want to make this video too long. I would say we'll probably get through maybe half of them, and then let you try the other half on your own, kind of like what we just did on the previous example. Okay, so when you solve a triangle, solving a triangle means you solve for all of the missing sides and all of the missing angles. And you do that using the trig ratios and only what's given to you in the problem. So even though you might find an answer for one of the sides, you won't use that side to find the other side and so on. You'll only use the given information. So let's take a look at example A. So in example A, we've got a side of length 9. We also have an angle of 44 degrees. So before we look for the two side lengths, let's find our missing angle, because obviously we've got 90 degrees here, we've got 44 degrees here. All triangles have to add up to be 180 degrees. So if we take 180 minus 90 minus 44, that should give us our third angle. You could probably do this one in your head. I'll just go ahead and type it in real quick though. So 180 minus 90 minus 44 is 46 degrees. So there would be your missing angle. So don't forget to also do angles. Now we need to find our missing sides. So again, even though we know this is 46, we're not going to use it. We're just going to use the 44 and the 9 that we were given at the very beginning. So let's solve for x first. X would be considered the opposite side, whereas 9 would be considered the adjacent side. So going back to what we would have done for example 2 earlier, let's set up a trig ratio. So opposite and adjacent, that would tell us to use tangent. So we would say tangent of 44 degrees is equal to opposite of x over adjacent, which is 9. And then to solve that, we're going to multiply each side by 9. So then x would be equal to 9 multiplied by the tangent of 44 degrees. And so x would be approximately, let's see, 9 tangent of 44 is 8.69. All right. Let's see. In addition to that, we also need to find y. And when we go to find y, we're going to have slightly different ratio we're going to use. So still looking at the 44, when we solve for y, y is your hypotenuse. 9 is still your adjacent, so I guess the 9 won't change, but now we're going to be using a different trig function. Adjacent and hypotenuse, you should be thinking of cosine. So you would say cosine of 44 degrees is equal to your adjacent side of 9 divided by hypotenuse of y, and then this time, since your variable is in your denominator, you'll do this kind of swap. And so then you would find out that y is equal to 9 divided by the cosine of 44 degrees. And so then y would be approximately, let's see here, 9 cosine 44, approximately 12.51. And there weren't any units, so we'll just leave this 12.51. Okay, so really I guess what I'm getting at is that you should be giving 3 things in your answer. You should be giving the missing angle, and you should be giving the 2 missing sides. Okay, let's do another one here. So looking at example B, let's kind of work this in the same way. So first thing is, let's find this missing angle. Again, we know the triangle has to add up to be 180. So take that minus your right angle minus your 33 degrees. It should tell you that the missing angle was 57 degrees. We'll check that over here real quick. 180 minus 90 minus 33, and is in fact 57. Okay, cool. So now, again, remember you're only going to get to use your given information to solve for the rest. So let's do this. Let's just solve for x first, kind of like we did last time. So for 33 degrees, 14 would be your opposite side. X would be your adjacent side. So opposite and adjacent, you should be thinking tangent. So tangent of 33 degrees equals your opposite side of 14 divided by your adjacent side, which is x. Anytime that variable is in the denominator, switch it with the other side of the equation. So x is equal to 14 divided by tangent of 33. And then we'll get our decimal approximation here. 14 over tangent 33, 21.56. Okay, now let's find y. So for y, again, we're going to use 33 degrees. 14 is still your opposite side. Y is now your hypotenuse. So opposite and hypotenuse, you should be thinking of sine. So sine of 33 degrees is equal to your opposite side of 14 divided by hypotenuse, which was y. Swap those two sides. So y is equal to 14 divided by the sine of 33 degrees. You can see that the equations are very similar that we're solving. And then we'll type that into our calculator. 14 divide sine of 33. Oops, not cosine. Sine of 33. There we go. Is 25.71. Okay. So you've got your missing angle, and you've got your two missing sides. Cool, cool. All right. Let's go ahead and keep this in order, because I think C would be a good one to work through. So for C, notice that now we aren't even given an angle to start with. We're given just two sides. So we're going to have to find the missing side. I'm just going to call that x. We also need to find the two missing angles. I'm just going to call those A and B. Let's do this. Let's solve for our missing side first. And this is something that actually has been around for thousands of years, and you probably learned about it way back in middle school at some point. To find the missing side of a right triangle. How do you do that? Think about that for a minute. The answer is kind of simple, but you might not be thinking about it. You actually want to end up using the Pythagorean theorem. Man, it's been a while, hasn't it? But yeah, Pythagorean theorem. So in order to do that, we're going to take our two shorter sides, so 14 squared plus x squared is equal to 44 squared. Notice that I'm not writing out a squared plus b squared equals c squared. That wouldn't make much sense because a and b are angles. So in this case, you can't even use the normal theorem like you would want to. But let's go ahead and solve this then. So 14 squared is 196 plus x squared is equal to 44 squared, which is 1,936. Okay, so then to get x squared, let's subtract 196 from that. So 1,936 minus 196 is 1,740. And then to get x by itself, we'll take the square root of our answer, which is 41.71. Okay. So that gets us our missing side. So that's one of our answers. We now need to find our missing angles. But notice that we haven't really had to find the angles. We've always been given at least one. So now what we're going to do is we're going to kind of think about, okay, we don't know what A is, but we do know the adjacent side was 14. And remember, even though we found a missing side, we're still going to use just the 14 and the 44. The 44 was our hypotenuse. So then if we were to try to set up an equation, what we'd have to do is we would have to take the cosine, since we're using adjacent and hypotenuse, but the cosine of A is equal to your adjacent side of 14 divided by your hypotenuse, which is 44. So now we're going to need something else to be able to solve this. We need to somehow get rid of the cosine. So this is where we've been thinking about this really for the past couple of units. You're wanting to know what is the inverse operation of cosine. And actually, that's just what it is. It's the inverse cosine. And the way we say inverse cosine is cosine to the power of -1. So with cosine to the power of -1, we're going to take that of each side of our equation. So cosine -1 of cosine of A is equal to cosine inverse cosine of 14 over 44. Oops, getting a little too close there. So what's going to happen, and what we saw with our inverses, is that inverse cosine and cosine are going to cancel, and you get A is equal to the inverse cosine of 14 over 44. Now this one I'm not familiar with, so bear with me while I find it. There, that wasn't too bad. So yeah, if you're using the Desmos calculator, just hit function, and there should be a cosine to the -1 button that you can use. And then you just type in your fraction, 14 over 44, and it'll tell you that the angle for A is approximately 71.45 degrees. On your graphing calculator, if you're using that, the button for inverse cosine is just right above cosine. So if you've been using that cosine button, just hit second cosine. That'll get you the cosine -1 button, and then there will be how you'll get your inverse cosine. Let's do that again here. So let's find B. So for our angle B, 14 is now not the adjacent side, now it's the opposite side, whereas 44 is still the hypotenuse. So when we go to find B, we're going to have to do that a little bit differently. We're going to use sine instead of cosine. So we're going to say the sine of B is equal to your opposite side of 14 divided by your adjacent side, which was 44. And then similar to what we did to find A, in order to get rid of the sine, we're going to use the inverse sign. So we're going to take sine inverse of sine of B is equal to sine inverse of 14 over 44. And again, what's going to happen then is sine inverse and sine are going to cancel. You get B by itself is approximately, and we'll type this into our calculator. So we'll type in sine inverse of 14 over 44. And that ends up being 18.55 degrees. Which then, if you wanted to check yourself, an easy way to do that is to take your 18.55 plus 71.45 plus your 90-degree right angle. Does that add up to be 180? And it should if we did everything correct. All right. So I tell you what, most of the rest of these are similar type problems to what C was. So I'm going to, let's do this. E and F we'll skip. Those can be kind of on your own if you wanted to try those. Let me do one more with you guys just to make sure it makes sense using some of those inverse trig equations and ratios, and then we'll be done with this video. So let's take a look at D. And it looks like we're going to have to kind of start it the same way. Let's again maybe call this side X, and we'll call one angle A and one angle B. So first off, to get X, which is your hypotenuse, we're going to take each of our shorter sides and square them. So 21 squared, or 24 squared plus 41 squared is equal to our hypotenuse squared, where 24 squared is 576. That plus, so the answer plus 41 squared is 2,257. And then we will take the square root of our answer. Tells us that X is going to be about 47.51. Okay, so we got our missing side. Now let's get those missing angles. So let's maybe start with angle A. So for angle A, again using just what we were given to start, which was the 24 and the 41. It looks like 41 would be our opposite side. 24 would be our adjacent side. So for opposite and adjacent, we would need to use tangent. So let's take the tangent of A is equal to opposite of 41 over adjacent, which is 24. Again, to solve, we'll then take the inverse tangent of each side of our equation. So what that'll tell us is that the A is equal to the inverse tangent of 41 over 24. And then we can type that into our calculator to get our approximate answer. So inverse tangent of 41 over 24 is approximately 59.66. Okay, so now let's go back and let's find our second angle. Let's find B. But now, once again, notice that our sides are actually going to be different. In fact, they're going to be switched around. And so now we've got our 24. I was thinking something and writing something else, but 24 is now our opposite side. 41 is now our adjacent side. So really all you'd have to do is from here for B, take the inverse tangent of the reciprocal. So switch around the 24 and the 41. And that'll save us a little bit of time when solving it as well. So inverse tangent, 24 over 41 is approximately 30.34. And I'll leave it to you to check to see, do all those angles that have to be 180. Looks like they will, but I'll leave that for you to check on your own. So yeah, at this point, E and F, if you want to try them on your own, that would be great to do. Guys, I do just want to also mention to you, we will start next week with section 9.4, which is all about the unit circle and using it. What that means, please make sure that you do the unit circle activity this week. So the unit circle discovery activity, make sure you do that activity before next Monday. So next Monday, I'll have our next kind of 3 sections of notes up for you to watch through. But in order for those to make sense, you've got to go through that unit circle discovery. So take some time at the end of this week here to do that unit circle discovery. The quiz on Friday, again, that's meant to just check to see how you're doing with understanding everything, won't have anything about the unit circle on it. But that still does not mean that you don't need to work on it before next week. So that being said, guys, have a great rest of your day, and I will have some more stuff for you next week.